Okay, let's keep going. Let's see 11, question 11. So we have arc sine of sine pi over 6. So first we have to recall arc sine is an angle, right? Let's call this angle theta. We can rewrite now as cosine theta. You know what? Let's use D because I don't have theta on my keyboard. Cosine D equals sine pi over 6. Let's call this D. So arc cosine is an angle D. So we can rewrite this as cosine D equals sine pi over 6. Sine pi over 6, we know is sine 30, which has beautiful value, which is a half. Cosine and sine are cofunctions differ this when the angle differ by pi over 2. Or when the angle adds up to be pi over 2. So we can take a look of a picture. So let's say I have a right triangle right here. Right, let's call this D, angle D. And the other angle is pi over 6. You see sine of this is the opposite. Let's call this B. Let's call this A. Let's call the hypotenuse C. So sine pi over 6 is the opposite is B over C. What about cosine D? Cosine D is also B over C. So those two called cofunctions. So sine D equals cosine pi over 6. Cosine D equals sine pi over 6. Because those two angles are complementary angles. So complementary angles adds up to be 90 degrees. And their sine and cosine are cofunctions, right? So when does cosine D equals to half? When D equals to 60 degrees, right? Or pi over 3, which means this angle D here is pi over 3. And indeed, pi over 6 plus pi over 3 is pi over 2. So complementary angles adds up to be pi over 2. Let's see the answer. Right, pi over 3. So that's 11. Now let's see 12. 12, we need to expand this polynomial. This binomial raised by 5 degrees. That's right, raised by 5. So first we could use something called a Pascal's triangle to construct the coefficients of each term. So we know the binomial, when binomial raised by 5, we'll get 6 terms. So each 6 term has a coefficient. So how do we get a coefficient? One way, there are 2 ways of obtaining Pascal's. One way we could get it from Pascal's triangle. Okay. What is a Pascal's triangle? Let's review. So we start with 1, right? Then we go down, write 1 on the left, write 1 on the right. We keep going, write 1. Now I have this one. So I get the middle one now. 1 plus 1, I get 2. Then I'm writing 1 on the other side. I keep writing 1 on the 2 sides. I need to add those 2 now. Those 2 adds up to be 3. And these 2 adds up to be 3. I keep writing this 1. I keep extending this 1. Now 1 plus 3, I get 4. 3 plus 3, I get 6. 3 plus 1, I get 4. So we see a symmetry here, right? And I keep writing this 1. So let's see. We need to construct a 5th level. So the first level is a 0 level. It's the binomial raised by 0, which is 1. Then first level. Second raised by 2. Raised by 3. Raised by 4. So we need to do one more layer. So I get a 1, 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. You see a perfect symmetry, right? Extend this, we got 1. Okay, so now we get our coefficient. So let's just write down our coefficient for the terms. The first term is 1. The second term is 5. The third term is 10. The fourth term is also 10. Then the fifth is 5. The last one is 1. Right. Then let's figure out each term. So I have 3x minus 2. I could think as a 3x plus negative 2. Right. The first term in those terms goes descending order. So the first term in the first place will be 3x raised by 5. And we don't see the second term yet. Or you could think negative 2 raised by 0. Negative 2 raised by 0 is just 1. So we don't bother to write it. Then plus the second term is coefficient of 5. Now the first term, 3x, now lowered 1 degree. So 3x to the 4th power now. As you can imagine, when in the third term, let's write addition all the way. So the third term you can imagine that's a 3x raised by cube. Right, let's just do the first term first. Then this will get a 3x squared. Then last one we get the 5 will get a 3x raised by 1. Last one is 1, right? It's this 1 here. Well, 1 raised by 3x 0. 3x raised by 0 just 1. So we don't need to really write it. So that's the first term in the binomial. So the first term goes descending order. You see the first one in the first term is a 3x raised by 5, then raised by 4, raised by 3, raised by 2, raised by 1, then raised by 0. The second term is negative 2. Negative 2 goes ascending order. Start from the first term, negative 2 raised by 0, which is 1. Then the second one will be negative 2 raised by 1. Third one will be negative 2 raised by square. Then keep going. This will be negative 2 raised by 3. Then negative 2 raised by 1, just negative 2. Then the last term, oh, hold on a second. I think I did something wrong. Not going downwards, going upwards, going ascending. I'm so sorry, those days in my head. My brain just doesn't function fully. So the second term goes ascending order, right? Starts from negative 2 raised by 0, negative 2 raised by 1, negative 2 raised by square, negative 2 raised by cube, negative 2 raised by 4. Then lastly is negative 2 raised by 5. All right, negative 2 raised by 5. So if you do this in the end, because you have to simplify each term, then you should get this as answer. 243 x raised by 5. All right, you get this big polynomial degree 5. Let's see question 13. We're given a sequence of numbers, right? We want to find a representation for a general term. So n can be 1, n can be 2. Let's see. She didn't see what n starts with. Let's assume n start with 1. N can start with 0, right? Or start with 1. So in this case, I'm letting n start with 1. So let's observe. The first term is negative, second term positive, third term negative, so the odd terms gets negative. So my an, I should have a negative 1 raised by n because I start with 1. Right, you see my first term is negative. So when n equals 1, indeed I get negative. When n equals 2, I get a positive. So I'm dealing with the signs first. So now the sign is down here, negative 1 raised by n's power. Now we observe the denominator. 3 to 9, let's multiply by 3. 9 to 27, let's multiply by 3. 27 to 81, let's multiply by 3. So I can write this in the denominator as 3 raised by n's power, right? If n equals 1, I get 3. N equals 2, I get 9. N equals 3, I get 27, so on and so forth. Okay, denominator is done, sign is done. Now let's look at the numerator. 11 to 14, add 3. 14 to 17, add 3. 17 to 20, add 3. So on and so forth, right? So this is add 3. So how do I get 11? For the first one, n equals to 1. If I do 3 times 2, 3 times 3, I get 9. So I need to, so how do I form that? So I can do 3 times n plus 2. That's 9. Then I need to add 2 again. I simplify this. I see I have 3n. Then 3 times 2, that's 6. Then plus 2, that's 8. So I can simplify this to be 3n plus 8. Right? Indeed, when n equals 1, 3 times 1, that's 3. 3 plus 8, that's 11. When n equals 2, I have 2 times 3, 6. 6 plus 8, that's 14, so on and so forth. Okay, so my numerator is 3n plus 8. Okay, so putting those 3 pieces together, all right. The sign, we have a -1 raised by n. The denominator is 3 raised by n. Then the numerator, I have 3n plus 8. That's it. That's the an's term. Okay, this is saying the first term is a1. Indeed, that means n started with 1. Okay, that's 13. Let's see, 14. Let me erase this first. 14, we're dealing with log expressions. So what do we want to do? We want to use a property to expand the expression. So now we have a single log, right? Inside the log, we see product. We see square root. We see division. All right. So first, I can have ln x cubed. Well, let's do step by step. Ln x cubed. Product means plus, right? I can split a product of one log into a summation of 2 logs. So ln x cubed, then ln of this y raised by 3 divided by z raised by 10. Square root means I raised by half, right? It means everything raised by half. Why do I want to do that? Because the exponent of the value goes to the up front. So this 3 goes to the front of ln. So that becomes 3 ln x. Plus, also similarly, this half goes to the up front of ln. So I get a half of ln, then y cubed. Y cubed. You see I have division, y cubed divided by z to the 10th power. So that can be split into ln y cubed minus, the denominator is negative, z to the 10th power. Right? So one more step. One more step is, let me change my color to be green. I see y raised by 3. So this 3 comes in front of this. And this 10 comes in front of this. So my last step is 3 ln x plus half times 3, that's 3 halves. 3 halves of ln y minus, now 10 multiplied by half, that's 5. 5 ln z. Okay, this is the final answer. All right. 3 ln of x plus 3/2 ln of y minus 5 of ln of z. Let's click on this. 3 ln x plus 3/2 ln y minus 5 ln z. Okay, let's see 15. We're almost done. We have 3 more questions. So let's erase all this. So a given function, quadratic function, we want to evaluate and fully simplify each of the following. F of x plus h, that means the input x now becomes x plus h. So we need to follow the function, but change x squared to be x plus h squared. Let me type. Okay. So that equals to 5, doesn't change, x plus h squared, then plus 4 times x plus h, because our input is x plus h, then plus 3. Then I simplify a little bit. Do I need to simplify? Yes, she's saying simplify each, right? So 5, I have perfect square, I have x squared plus 2xh plus h squared. Then plus 4 times x, that's 4x, plus 4 times h, then plus 3. So I get 5x squared plus 5 times 2xh, that's 10xh plus 5h squared. Then plus 4x plus 4h plus 3. We don't get a like terms. So that's it. You see here, this is a 5x squared, no like terms. 10xh, no like terms. 5h squared, no like terms. 4x, no like terms. 4h, no like terms. Constant, no like terms. So that's our answer. That's our answer. Let me erase so you can see clearly. 5x squared plus 10xh plus 5h squared plus 4x plus 4h plus 3. Okay. Now we use this one to subtract f of x. Well, f of x is this, right? Let's move this one to here. We want to subtract those two. Then divide by h. Let's subtract first. So when we subtract, we see 5x squared canceled. Then 4x canceled. And 3 minus 3 becomes 0, canceled. So we're left with 10xh plus 5h squared plus 4h. So everyone has h in it. Then we divide by h. Divided by h, what's left? 10xh divided by h, that's 10x. 5h squared divided by h, that's 5h. Plus 4h divided by h, that's 4. So our answer is 10x plus 5h plus 4. 10x plus 5h plus 4. Let's see next one. Oops. 16. Almost done. 2 more questions. So we want to add this many numbers. We need to use our formula. Right? Let's see which formula we should use. We observe the sequence. Basically, we sum up a sequence of numbers. So from -2 to 8, let's multiply by -4. From 8 to -32, let's multiply by -4. So this is saying we get a geometric sequence. So geometric sequence, the sum of nth term equals to the first term, in this case, which is -2, times 1 minus the ratio. What ratio is -4, right? Minus ratio, -4 raised by n's power. So we need to figure out the last term is in which position. This n represents the position divided by 1 minus -2, -4, the ratio. So let me write the ratio on the side. So ratio R equals to -4. So the sum of a geometric sequence equals to the nth term. the sum of nth term equals -2, equals the first term, which is -2 in this case, times 1 minus the ratio raised by n divided by 1 minus the ratio. Well, this will have 1 minus -4, so this becomes 1 plus 4. 1 minus -4 becomes 1 plus 4. Okay, so that's our formula. Now we need to figure out the number n. So which term is this? So it's position, the position of this term. So how do we figure out that? We have another formula. It's called an, the nth term for geometric sequence equals to the first term, which is -2, times the ratio, which is -4, raised by n minus 1. Right? In this case, this is -131072. Such a big number. 131072, right? So first, let's divide it by -2, because both sides will have -2. Right? This side we have -2 as a factor. This side will have can be divided by -2 also. So we divide by -2 on both sides. Then we get a -4 raised by n minus 1 power n minus 1 equals to, if we simplify this, negative times divided by negative become positive. 13 divided by 2 we get 6. Then remainder 1, well 11, 5. Then we remainder 1, 0, that's another 5. Then 7 divided by 2 is 3, remainder 5. Then we have 12. 12 divided by 2 is 6. So we get a 6, 5, 5, 3, 6. Okay. One way we could do is we just keep dividing 6, 5, 5, 3, 6 with a 4. Let's see. If we divide this by 4, because the other side is 4, we want to be able to write 6, 5, 5, 3, 6 in the base of 4, 4 raised by the power. So that's one way of doing it. We can also take a logs, right? Log base 4. Log base 4, that's another way. Okay, so let's divide by 4 first. So I have 4 times 6 divided by 4, that's 1. I have 25. That's 6, I remainder 1. I can put a 3, I remainder 3. 8, 32, I remainder 1, so 4. Let me check. So maybe I could, let me use my calculator because my brain recently doesn't function well. So I have 6, 5, 5, 3, 6 divided by, actually, let me start from the very beginning. I have 1, 3, 1, 0, 72. First, I need to divide by 2. 1, 3, 1, 0, 7, 2 divided by 2. Oh, yes, I did. Okay, 6, 5, 5, 3, 6. Now I'm dividing by 4. I got a 16384, 16384. Okay, I did it right. Divided by 4 again. Divided by 4 again. So I get, let me just keep writing it. Okay. So now I have 4 squared, 4 times 4 times 6, the 4096. Then I divide this by 4 again. I get a 1024. I think that's 4 raised by 3. Let's divide it by 4 again. Divide by 4 again. I get a 4 times 256. 256 divided by 4, that's 64. 64 divided by 4, that's 16. 16 is a 4 square, so this is 4 cubed. So how many 4s I have? I have 3, 4, 5, 6, 7, 8. All right. So this number is a 4 raised by 8. Let me just double check. So 4 times 4 is 16. So that means this number is 16 raised by 4. 16 raised by 16 is 256. That means this number is 256 multiplied raised by 2. Yes. Okay, so 4 raised by 8. So that means what? N minus 1. What does this minus 1 do here? That means negative 4 raised by n. You can see raised by n divided by what's negative 4 raised by negative 1. Negative 4 raised by negative 1. That's negative 1 over 4, right? Remember, something raised by negative 1 means 1 over it, but we still have negative. So I can divide by negative 4 here. That equals to 4 raised by 8. Then I multiply negative 4 on both sides. Right? I multiply negative 4 on both sides. When I multiply on this side, this canceled. When I multiply on this side, I get a negative 4 raised by 9. So that tells me my n, you see, I have negative 4 as a base now. Other side I have negative 4. So that means n equals to 9. That's how we figure out n. So which means this is a 9th term. Okay, now we just plug in n equals 9. So n is here, n is here, n is 9. So we have negative 4 raised by 9 divided by 1 plus 4, which is 5. So let's do this calculation. So we have negative 2 times 1 minus negative 4 raised by 9, because 4 raised by 8 is 6, 5, 5, 3, 6. Now multiply by 4. Let me write down this number. It's a huge number. It's a 2, but it's negative though, because negative 4 raised by 9 is negative. But 1 minus negative becomes 1 plus. So that's a 262, comma, 144. 144. So that's this number, then divided by 5. Because 1 minus negative 4 becomes 1 plus 4, which is 5. All right, so we add 1 to this number. That becomes 262145. So the inside, because I add this 1. So this 4 becomes 5. So this can be divided by 5. If I divide it by 5, I get 5, 2. Let me type. I get a negative 2 times 5, 2. This is very easy to make mistake. 429. So that's why it's important to double check. Then when we multiply the negative 2, we get a negative 104,858. Okay, let's see if we did it right. Let's check the answers. Oh, yes. Negative 104,858. So during the calculation, it's very easy to make mistake. So make sure every step you check. Okay. Now let's go to 17, question 17. Let's erase this first. 2 more questions. So we want to write this equation of an ellipse. Right? Remember the equation of ellipse? One side equals 1. Right? We want to be able to write this as a 1. So on this side, we want to write it as x minus some number square, then divided by a square plus, maybe let's use h, plus y minus k square, oops, divided by b squared, right? We call major axis, minor axis, depends on which one is bigger. The bigger one is called the a and b. If a is bigger than b, we call a the major axis, b minor axis, or otherwise vice versa. So here, let's see the x term. We have 9x squared, 18x. Okay, we're gonna put those two together and factor out 9. So factor out 9. Then we put x squared. Well, 18 divided by 9, that's 2. So plus 2x. So we rewrite 9x squared plus 18x as this. Similarly for y term. Y term I have 16 as a leading coefficient. I'm going to factor out 18. Then I have y squared plus 160y divided by 16, I get 10y. Right. Then what do I do with 265? I move to the other side. When I move to the other side, it becomes negative 265. So now I'm going to completing squares, right? Completing squares means, so I want to make this one a perfect square. I want to make this one perfect square. How do I do that? I take the number before x, I divide by 2. 2 divided by 2 is 1. I add 1 square from here. 1 square is 1, right? Same time, I'm adding 1 on the other side of my equation to hold the equation still to be true. For this one, I take 10, I divide 10 by 2, I get 5. So I'm going to add 5 squared. 5 squared is 25. I'm going to add 25 on the other side of the equation as well. Oops. Okay. Oh, you know what? I made a mistake. Can anybody tell me what's the mistake I have made? Let me use a different color. I did not only add 1. I want to add this one inside. So this one is 9 because I have a common factor, 9. So this one is not a 1, but a 1 times 9. And this 25 also, I want to add inside the parentheses. So I have to have 25 times 16, right? What's 25 times 16? 400. So I'm not adding 25 to the other side. I'm adding 400 to the other side. Okay, by doing so, now I have a perfect squares. So this is the process of getting perfect square. So I get x plus 1 squared, then plus 16 parentheses x plus 5 y plus 5 squared. Then equals 2. So on the other side, I can do some calculation. I have 400 plus 9, that's 409. Then minus 265, I get a 144. Beautiful number, because 144 is, okay, 144 has a factor of 9, has a factor of 16. So now what I'm going to do. Remember in the standard formula, I have the other side equals 1. That means I need to divide every term by 144 to make my right-hand side to be 1. By doing this, so 9 divided by 144, what do I get? I get x plus 1 squared divided by 16, right? Because 9 times 16 is 144. Then the y term is y plus 5 squared divided by 144 divided by 16, that's 9. Now 144 divided by 144, that's 1. So now we're in the standard form. I have x plus 1 squared over 16. 16 is 4 squared, plus y plus 5 squared divided by 9. 9 is 3 squared. So that's our standard form. So what is the center? H comma k. In the standard formula, we have x minus h, y minus k. So that means h is -1 and the k is -5, right? Because x minus -1 becomes x plus 1. Y minus -5 becomes y plus 5. So that's for this question. Let's check the answers. X plus 1 squared divided by 16 plus y plus 5 squared divided by 9 equals 1. Check this answer, -1. This answer, -5. All right, so last question. Last question, let's erase everything. Erase everything. So last question, we want to verify this trig identity, which means we need to start from one side, then in the end, get to the other side. Okay, so let's start from the left-hand side. Left-hand side, cosine, tangent t is sine t over tangent cosine t, right? And cotangent t is cosine t divided by sine t. So we start from left-hand side. Maybe we even write it. That is it, left, L-E-F-T. Left side equals to. Right, left side equals to. So we rewrite tangent t as a sine divided by cosine. We write the cotangent as a cosine divided by sine. So we need a common denominator for those two. So what do? We need to multiply by 1 for each one. And the first one, we need to multiply sine t over sine t. So we get a sine square t. I'm going to typing is easier for me. Get a sine square t, then plus cosine. Second one, I need to multiply by 1, but this one is cosine t divided by cosine t. So cosine t, cosine square t, then all divided by my common denominator. My common denominator is cosine t times sine t. Right? What is sine? Oh, I'm missing square. Sorry. Sine square. Cosine square. What's cosine square plus sine square of the same angle? 1, right? So I get a 1 over cosine and sine. 1 over cosine and sine. Well, what's 1 over sine? What's 1 over cosine? 1 over cosine is a secant. 1 over sine is a cosecant. So we have arrived at our right-hand side. So secant t and cosecant t. And that is our right-hand side. So we have done it. Maybe we write equal sign here. So the left-hand side, this shows left-hand side equal to this, left-hand side equal to this, left-hand side equal to this, left-hand side equal to this. So this equals to the right-hand side. Right side. Okay, so to verify, to prove, you have to go this way. You can start from the right-hand side, then arrive at the left-hand side. That's fine too. But you can only start with one side, arrive at the other side, okay? And that's it. And good luck, all right? Good luck for exam.